Welcome everybody. My name is Stephen Feuerstein, Oracle Developer Advocate with a focus on PL SQL. And I'm here to host a session, an Ask Tom office hours session on database setup and teardown for testing. In fact, let's move my slides ahead. Welcome to Ask Tom office hours. Yes, so many of our office hours on PL SQL feature myself and Chris Saxon, a member of my team, who focuses not only on SQL, but mainly on SQL, but also on everything Oracle database. But lately, I've been really enjoying inviting experts from our community. We have so many thousands and thousands of people who are dedicated, deep experts with real-world experience around Oracle database technology, SQL and PL SQL. And I love to bring them on board to learn, so we can learn directly from them. So my plan today.
Sorry.
No problem, Dee. So my plan today is to have two speakers, Dee Bandari and Jasmin Fluri, to present on a really interesting and challenging topic. We all know how important it is to test our database code, but database testing or testing of code that's in the database, PL SQL, SQL, is generally difficult. Testing any code is difficult, but even more so when you're talking about database-based code, because then there's an external dependency. It's relatively straightforward to test code that's deterministic. Each program stands on its own and you can just test its inputs and its outputs, and wow, you're so lucky, that's so easy. In the world of database, you have this external dependency, obviously, on the database, which means that setting up the database state to prepare for rigorous, automated, consistent testing, and then tearing down that state is a critical and challenging job. And it's often one of the big barriers to people getting up and running on automated testing. So I thought I'd follow up on a really successful, popular session from the end of last year on automated testing, which Dee and Jasmin also participated, to do a follow-up on the specific topic of database setup and teardown. Go back and share my screen. So that's the plan. Quick reminder, sorry, I guess it's an advertisement, but it's an advertisement for free stuff. So we have an Oracle Cloud, we have Oracle Cloud Database Services, autonomous database, tons of stuff in the Oracle Cloud, but we also have an always free tier. So you can now have an Oracle autonomous database running with Apex and/or it's doing REST APIs, SQL Developer Web. So many possibilities for application development on Oracle database for free. Check it out, give it a try. So as I said, database testing is hard in general, but it's even harder when you're doing database testing. And so the intention of this session is to help you learn about some techniques in the real world that can help you get going around automated database related code testing. My two speakers, Dee Bandari, who's a senior software engineer at Fidelity Investments, and she brings a lot of experience and passion to coding in general and specifically around testing. Really enjoyed you last year. Looking forward to the session today. And then we'll have Jasmin Fluri, who's an independent consultant at Schaltstelle. I might have pronounced that correct.
Yes.
And is very active in both lecturing to students on development and doing development herself with a specific focus around automation, DevOps, and testing. So what we're going to do is have Dee present first, and then Jasmin present afterwards. In case you haven't noticed and you've been on these office hours sessions before, your environment in Zoom might look a little bit different. We're now doing a Zoom webinar as opposed to a meeting, so there's a separate Q&A area for you to ask questions. You don't have to, but you still can ask questions in chat. And otherwise, your experience should pretty much be the same. So I hope you enjoy it. Ask questions in the Q&A in the chat. I'll pick them up and either transfer them immediately to the presenter or wait until their presentation is done. We should have lots of time for Q&A today. So dive in, and also, we'd love to hear your experiences on these same topics. Dee and Jasmin have a lot of experience. You have your own experience. Please share. And with that, I will turn it over to Dee.
Thank you, Stephen. I am going to share.
That's pretty.
Okay.
And that's a PowerPoint.
Yep. Okay. So I am, first of all, good morning, everybody. I am Deepti Bandari, a senior software engineer at Fidelity Investments. I've been working here since 2013 and currently very focused on Oracle databases. I enjoy designing and developing complex database systems, test automation, and I love promoting engineering excellence. I also love learning and sharing my knowledge. So I'm here to share my knowledge and my experience about database testing, and specifically database data setup and teardown in testing. Some challenges that I have faced personally, and some tips and techniques from my end. We've already established how important testing is in the November session, but I do want to quickly touch on the first principles of unit testing. I believe they're from the book Clean Coder by Robert C. Martin, because it helps kind of set standards for not just testing, but also for setup and teardown. First principle stands for first, isolated and independent, repeatable, self-validating, and thorough. Sorry. So the time it takes to run a test not just includes the test itself, but actually the setup and teardown. And your project could have thousands of tests. So we have to make sure that tests run really fast in a matter of like milliseconds or seconds. A developer should not hesitate to run tests because they're slow. And a test should do all of the 3 A's, that is arrange data, which is set up all the data required for the test, act, which is call the procedures that are being tested, and also assert for a single behavior. And a test should always pass or fail in the same way in a suite, no matter how it's run, whether it's run in a suite or is run individually. The order of run should not matter when running tests, and tests should always yield the same result in every environment they're run. They should not depend on any specific environment, because then you're tying your tests to the environment itself. There can be certain exceptions, which we'll talk about later in the presentation, but we have to ensure that they do yield, they have deterministic results always. Self-validating, there shouldn't be any manual intervention to check whether tests have passed or failed, and test cases should cover every use case scenario and not just aim for 100% coverage. I wanted to touch on this so that we can keep this in mind, and then dive into a little bit about the challenges in data setup and teardown. So moving on, setup in relational databases with a lot of foreign keys. Personally, this is something that I faced, and I don't like it. And I'm sure it's a big headache it's a big headache and frustrating for many developers around the world, and it's a challenging problem that everybody's trying to solve right now. But imagine a very complex system with a lot of tables connected by foreign keys. That is, one table can have many parents, and those parents can have many parents. So how many such tables do we have to set up for writing tests? The more data that you have to create or set up for your tests, the slower your tests get, and so does the development cycle. So you can understand the frustration of a developer when you have to do all this. And tearing down this data also comes with a cost. Like, the more data you have to set up, the more data you have to tear down. And it definitely contributes to the slowness. And when teardown is not done correctly or in the right order, it leaves the environment in a bad state, and then tests are not repeatable anymore. The other big thing I've noticed is when one big setup or one big teardown procedure is shared across hundreds of tests in a package. I've seen this one setup proc with like thousands of lines of insert and insert statements, and there's no clear distinction between no clear distinction as to what data is used for what tests. So this code is not only hard to understand, it's very hard to read, and it gets impossible to manage such kind of code unless there's like heavy comments, which is I don't know. Some people do it, some people don't. So it kind of gets hard to even understand the code base for someone new. And the fourth challenge is relying on existing data in an environment. When you know exactly which environment you're developing and testing in, it can be very tempting to use the data that's already there in the database. But this way you're tying your tests to an environment, and what happens if the environment gets refreshed with different data, or you have to move on to another development or testing environment. Obviously, all the tests that were dependent on the data will now break, so your functionality is broken. These are something that I've personally faced, and I've been constantly trying to learn how to solve these problems. And along the way, I've implemented some of the tips and techniques that I'm about to share to overcome those challenges. But I can stop for a second if anybody has questions regarding the challenges.
No questions logged yet in the Q&A so far, Dee, but I do encourage all of you, if you have questions or comments, go ahead and use the Q&A. You can also use the chat, but the Q&A will be better in terms of tracking the conversations.
Awesome. So tips and techniques, the first thing I started incorporating in my code is using UTPL SQL v3 annotations. It's really fancy, and it really there's some very neat solutions for some of the challenges that I just mentioned. For example, you can use before all, before test, before each annotations to set up data in a way that you can share the setup. So depending on how many tests need the same data, and if the tests are modifying this data, you can use the setup at different levels. Before all sets up data at the package level. You can also share data at the suite level. Before test sets up the data for just right before a particular test. So it sets it up, runs the test, and tears it down automatically. Before each is something is set up that runs before every test in the suite. And the corresponding after all, after each and after test, clean up the data for you. So these annotations give you the flexibility to modularize data setup procedures, organize and clearly distinct which tests are being used for, which tests are using what kind of data.
So Dee, I know that you're going to show some code soon. And
yes, I am.
Just a couple of things. I had one question come up. Newbie here, please describe UTPL SQL. And the other thing is well, why don't you go ahead and do that a little bit?
Yeah, it's a testing framework for testing PL SQL. The version 3 is the newer version. So it basically has, it's almost, I would compare it to JUnit because it has all this concept of annotations and all of that. It's much more cleaner. It has all these features.
Great, that's exactly what I wrote in the chat as well. So the way I would frame it, right, it's like JUnit for PL SQL, and the idea is that you write the test code, but then the framework will run your test for you and report on the results. Thanks.
Okay. And I talked a little bit about rollback just now. UTPL SQL also has a very fancy feature of automatic rollback, but provided there's no transaction control in your code package that you're trying to test. So when you do have transaction control, or when you do need transaction control, maybe if you can separate out the business logic from transaction control, you can just test into two procedures where you can, or multiple procedures where you can test only your business logic and not worry about tearing down data, because the framework automatically does it for you. I have some examples later to show for this one too.
Great.
So relying on existing data in environments. I know we kind of said that we should set up all of our data and things like that, but there are instances where there's constant or static data in and across environments in a pipeline. And if it's guaranteed to stay that way, it is okay to use this data for your tests. Oops, sorry. And then some of the data setup that's shared can be provided via scripts that run in a timely fashion. But these kinds of scripts must live with your source code so that when you go to a different environment, you can ensure this data is always available. So you can use this and run your tests. But it's really important to have it in version control. And the last tip that I have here is setting up only the minimum data required for tests. So it's very easy to get lost when you're trying to set up data for your tests and set up too much data that you probably don't even require. But this will increase your development cycle time and also the time it takes to run your tests. So you'll really, you just have to, I guess, determine what kind of behaviors you're trying to test and determine what data is required for those tests before trying to start setting up this data. For example, imagine there's like a table with 50 columns and 5 not null columns. There could be 2 scenarios or 2 behaviors you're testing for. And depending on that, you can do your data setup. One is a test might require data in this table only for the purpose of referential integrity. So in that case, you don't need to set up all 50 columns. You can just get away with setting up the not null columns and use the key in your test, in your data setup. And the second scenario is you may want to test or validate that when you're loading into this table, all of the columns are populated correctly. So in this case, you kind of have to set up almost all of the columns if you are trying to validate that. But it's, like I said, it's based on a use case base. I'm going to stop there for a second.
We have a question.
Go ahead.
How do you handle IDs sequences? Each time the test runs, we get new IDs, so we cannot rely on them to check the test results. But not every table has an additional unique key. Any recommendations or experiences with that?
Yes, actually, I do have an example for that too, but let me switch over to my, this is what I do. I was going to do this later, but.
And just one point as you're getting into that. So it's pretty clear that when you have generated values, like, basically random generated values or uniquely generated values like identity columns or sequences, yes, you will not be able to check those values specifically. No question. Okay, go ahead, Dee.
Yes. And considering that sometimes it's like in my database here, I have sequence numbers, but they're going to be positive. So I use negative numbers for my tests. So I actually know exactly what I'm putting in. And I can validate even that.
Okay.
So that's one of the ways you can do it.
But it seems like usually what you'll do is not any test for validating the data sets will exclude those kinds of columns.
Yes, and UTPL SQL actually has a .exclude function that you can use to exclude certain columns when you're comparing data as well. So that's another feature if you've seen that. So this is the one actually. I do have it luckily. But you can exclude the ID columns when you're comparing actual versus expected. Okay, moving on. So I talked about the challenges and some tips and techniques. I also want to show some kind of code examples for those tips and techniques. And I chose to showcase my pet project. and I wanted to make it something a little fun for everyone, and hopefully people relate to this one. But I have this smart home, very, very high level design of a smart home application in the database tier. And the high level use case of this application is when I say good night, the following things must happen. For example, the following tasks. This is what I call them. There's routines called good night or clean the house or goodbye or going away. And there's a bunch of tasks that need to be executed as a part of that routine. For example, turn on the thermostat upstairs at 10:30 p.m. or announce in the living room that it's time for bed. Turn on heater, turn off heater downstairs at 10:30, or dim the lights upstairs. That should be upstairs at 10:30, and so on. So pretty fancy if I get there for my house, but we'll see.
Very fancy.
And here is a very, very high level data model for this one. And it's not perfect, but it helps me achieve what I want to today. So basically there's a home table, and a home can have owners. A home will have floors and rooms. And there are routines which consist of a bunch of tasks. And a task has a bunch of parent tables, because a task is nothing but a set of, turn on is an action, thermostat is a device, upstairs is either a floor or a room, depending on what you pick, and time is when you want that to happen. So based on that, this is the model. So there's a device, floor, room, action table, and routines. And a routine can be active or inactive. So if a routine is active, you can invoke it. So you can see that I said it's a very simple high-level design, but there's already around 12 tables that you may have to set up or tear down when you're writing tests for this application. And I do have specific scenarios that I'm going to show. For example, invoke a routine. So given a routine name, when a routine is set up with tasks, then I must get back the list of tasks. And when the routine is not set up, I get back an empty cursor. So that's the behavior. Those are the behaviors I want to test. So for that purpose, I have written one function, which serves the purpose for now, but there could be multiple functions later. It just invokes routines by name. You pass in a routine name, and it returns a cursor with all of these details. So routine name, a task, and all of the task details. I'm going to switch now to SQL Developer, where I have the code for this. So this is the function that we just saw. And as you can see, for testing this, I want to test two different scenarios, two different behaviors. What happens when a routine exists and what happens when a routine doesn't exist. And in order to set up data for these two tests, I would need, first of all, a home and some routines. But the setup for home and its floors and rooms doesn't have to be done every time. It can be done once before all of the tests in this package, and it can be torn down at the end of the package. So that's why I chose to put them in the before all. Basically set up one home and set up multiple routines later when I want. And when it comes to the routines for the home, this kind of data is used by multiple tests in the same package. And I may want to even modify certain routines going while I'm testing. So I do want to bring it, when I set up a routine, I want to bring it back to the original state. So I've asked to set up the routine for the home before each test runs. So it sets up once before existing routine, tears it down after, and then sets up once before non-existing routine and tears it down after. So if you go to the actual test. This is the test for existing routine. And I've said that data has been already set up using the before all and the before each. And this is my expected, because I know what I set up, this is my expected result. And this is where I assert by calling the function that gives me the task under a routine. And sorry, this is my act, and this is my assert, where I'm asserting the actual value to what I'm expecting. And I'm doing the same here for a non-existing routine. But I know that I set up test routine as a part of before all and before each, but I also did not set up this routine called routine not set up yet. So I know that this will return an empty because that's the behavior of my functionality, of my use case. So this is what I assert against. Now, if I go back to my slides, there's one other scenario, and then I can show the test results. The next scenario is, given a routine name, when the routine is active in my system, I get back a Boolean value as true. And when the routine is inactive in the system, then I get back a false. So based on this, I can determine if I can invoke a routine or no. So it's a very small, simple use case. And for this purpose, I have an isRoutineActive function, which takes a routine name in and returns a Boolean value. Going back to SQL Developer, here's the function. And when I go to my tests, so one thing I do, okay, actually I'll get to this after, but these are the tests that I want to test for active and inactive routine cases. And if I go to the test, oops, I know that my test routine that I set up using before all and before each is an active one. So all I'm doing for my test is checking if my test routine is returning true. And it does. But when you move on to the next one, I know that I'm not setting up any inactive routines before this test itself. So, and I might be using those inactive tests elsewhere, or I may not. I don't know that yet. So what I did was I am setting up an inactive routine only before the inactive routine test. So that way I don't have to do it all the way up because it's not being shared by anything. So I set it up only for an active routine and it tears it down automatically. So if I go to the tests now, you will see there were 4 tests run. One for getting the status of a test, whether it's active or not, and one context for getting routine details based on routine name. So a few things I want to point out in this one is the ability to group tests using context. Notice I don't have any after all, after each, or after tests because my code doesn't have any transaction control. And I'm using UTPL SQL's, I'm leveraging UTPL SQL's teardown functionality, and it's happening in the background. I literally don't have to have any delete statements in my test package, which is pretty neat.
That is nice.
And there's one other thing I wanted to show about the separation of business logic and transaction control. in case you need to have transaction control in your code, I suggested having business logic and transaction control separated. So for example, when you have to save a routine, a new routine, let's say, you pass in all the details of a routine and you get back whether it saved or it didn't save, a message basically. I don't have this function implemented yet, but I do have the spec. So I wanted to show the one. So this is the save routine, which kind of is kind of like a wrapper that does something with the input and then it commits. So it basically passes on the do something with the input to another function or procedure that takes care of all of the business logic, and all it's doing is a commit. That way, when you're testing for any of the save routine functionality or use case, you can call the business logic functions or procedures and not worry about teardowns, because then you wouldn't be committing here. You can just leverage the teardown again, automatic rollback again. And sometimes if I go to the test package, let's say this get routines package is one test package. There could also be one for test set routines package, and they both might need to set up homes for all of the tests. So you could move this up outside of so that it can be shared between packages using the sweet path as well. I think that's all I had. I do want to conclude by saying that I know the data setup and teardown is the most challenging thing for developers while testing, but it is kind of the foundation for testing. And I hope some of these tips and techniques helped a few of you folks. And I hope you guys were able to relate to my application. Thank you.
Thank you so much, Dee. Okay, so let's transition over to Jasmin. And Jasmin, I'm going to make sure you can start your video since I turned it off before. That was so rude of me.
Great.
There you are.
My video should have started. Okay, can everyone see this?
Cannot yet see your screen, but I can see you.
Okay, oh. Okay, now it should work. Are you seeing my screen?
Yes.
Yes, great. So Dee already showed us some unit tests and examples of unit tests before. What I want to show here is maybe something for the newbies that never seen a test case in concept. I call it architecture of a unit test, or the concept of a unit test. What we see is a test case that calls a test object and delivers us the actual results. Those actual results we can compare then in the assert statements with our expected results and give us then the test results. The test case is wrapped, I call this wrapped by preconditions and postconditions. It's the setup functionalities and the teardown functionalities, like as Dee showed. It's also called the before each, before all, after all statements that are executed before or after the test cases. For all of you who want to see how it is executed when we use those before all and after all statements, this is an execution line along the arrow. So we have the before all statement or procedure that is called, and then have all the test cases. And after all the test cases, or after the execution of all the test cases, the after all statement is run. If we use more annotations, in this case, before all, after all, before each, and after each, it looks like this. We have the before all at the beginning, and then the before each, before the test case, the after each, after the test case, and so on, until the after all until the end of at the end of the execution of the tests. So if you thought about how the execution is, that's pretty much the picture you can have in mind when you are running your test cases. Something about the naming of the unit tests. We call a test package a test suite, and the test itself, it's a test case. Within a test context, we can have one or multiple test cases that are ran. Important is one test context tests one functionality of our production procedure. It gives us the possibility to group all the tests that do test the same thing in one context. It's easier to manage, and we can very easily find the tests again if we are developing. Then the productive procedure is called a test object, and there we have the productive procedure itself. It's the object under test. If we develop database tests and functionality, usually the highest goal is to version control all of our code. That's the most important thing for us. So we develop the tests and also the test data as a developer and put it onto version control. And the goal is then that continuous integration tells us how the tests perform, if our application is still running, and if we have a successful integration of our application. That's where all the unit tests are used, and that's where the unit tests tell us if we did a good job or if we didn't, or if we broke something. If the continuous integration passes, the deployment starts and goes through the deployment pipeline. Important here is that the unit tests and also the test data should only be deployed in the test environment. We don't want to have the test data in the production environment. We only want to have that in the test environment, because the chances of breaking something in production would be too big. So all unit tests and also the test data belongs into version control. We want to automate the execution of our unit tests in the continuous integration, and we don't deploy unit tests or test data to production. This leads us to the management of test data. When I said that all the tests need to be in version control, my project structure should look something like this. I have my project here and some documentation of the project. And then I differentiate between database objects that contain all the production objects and functionalities of the application, and the tests, which contain test packages and the test data. So we have production code and we have test code and test data clearly separated. It is clever to have some similar naming of test packages and the production packages to make the navigation easier. If I want to find out in what package my production package is tested, I want to have the test package to have a similar name so I can find it easier. I store the test code and test data separate from the production code. Usually we have one test package per production package that we are testing. And we store the test data and the test functionality separate from each other. This has reusability reasons for one thing, and it's just also clearer to have them separated, to not have large packages with only data in it. The unit test development cycle then looks something like this. We define a test case where we answer what do you want to test. or what do we want to test. We create our test data, which is an essential part of the development of our test, and define here what do we need to test what we want to test, what are the preconditions. Maybe we need to fill some tables with data. Then we set up the test harness. A test harness I call the before and after statements, everything what's around our test. So how does the database need to look like for the test is the question here. The implementation of the test then continues. How do I test it? I write the code and then run the test. Is it working? Is it not working? If it's not working, I need to implement it again or change the implementation and then can run it again. This has some requirements for my test data that I need to have. I want to have the possibility to review my test data during code reviews in pull requests. This is very important for me because when I write tests, I want my colleagues to give me feedback on it in pull requests. And if they only see my tests and not the data, it's hard for them to know if I have thought about everything. If they also need changes in the data, that will also be in version control. They can decide if the test will work. They can try it out themselves. Then the test data has to be stored per tables. I will show an example later on about that. It's more that every table should have the possibility to be provisioned on its own. So I can choose which table I want to provision or not. Then the test data needs to be flexible to be reused by multiple test contexts. Test data needs to be updated together with the newly or changed functionality. If I change functionality, maybe I also need to change my test data because it doesn't apply anymore to the changed conditions that I want to test. And if I have new functionality, I maybe need to add also new test data so that I can cover all the test cases. I will show a short test management example with this small database schema. It's only an example. I have a person. Persons have addresses, and one person can have multiple addresses. So I have this table in the middle that assigns persons to addresses. I have the test data package, which contains all the provisioning functionality of the 3 tables I have. And it contains also a setup and teardown procedure for the setup and teardown of the data. The goal here is only to provision the tables with data. The test data package body looks about like that, a bit simplified. I have an insert data into person procedure that inserts data into the person table, and have the same thing for addresses and person addresses. The goal here is to have as little test data as possible. Dee already also mentioned that. We don't want to have thousands of rows of data. We want to have the optimal data to test all our test cases that we want to have. Some negative tests, some positive tests, and don't just want to have a lot of data. Then we want to have one procedure per table. I also mentioned that. To make sure I can only provision the tables that I really need. Then the setup and teardown procedure looks about like that. I have an insert data into person functionality call where the tables are provisioned, and the teardown functionality then truncates my tables again after I ran the tests, because after the tests I don't need the data in the tables anymore, and if it was changed or manipulated, I cannot use it for another test run. And in that way, the test data is also treated as application code, which I want, because then a review of the test data together with the test functionality is possible. I have a unit test package. It's called test package. What it does is in the before all, it calls the test data setup method that we saw before that provisions all the tables I have. And from that point on, all the tests that are executed after this setup can use the data that I inserted into the tables. And this is the start of my test context. Now begin all the tests for a certain functionality. I have a first test, the end of the context, and the teardown happens after all the tests are executed. So the tables are truncated again. It would be also possible to have a test data setup in before each annotation, so that the setup would be done and tear down before and after each test, what would probably lead to a lot longer test run. So be very careful if you provision tables. That takes a lot of time, and you don't want to provision your database completely new for just one test setup. Just think before you set up your tests. It should be optimal also in the time perspective. So the summary is keep your test data where your application code is, so people can review it and you have it all together and are not dependent on any other systems. Separate production logic from test logic and test logic from test data. As we saw in the example before, the test doesn't contain any provisioning anymore. It's only calling the procedures that contain the provision methods. Data collection, maintenance, automation, and data management is the job of the developer. So it's your job essentially. Always create a fresh set of data according to the requirements of your test case. If you have new test cases, just change and extend your data. And if the functionality changes, also change your data if you have to. And sample test data should be consistent and represent the production data. So you should have a sense of what your production data looks like. If you don't know how it looks like and don't know how it feels, just go and have a look if you can, because test data that is completely different from production data won't do the job probably. Yeah. Oh, and always test on boundaries. Last point.
One of the trickiest aspects of testing, right?
Yes. It's also where you need the littlest or the smallest set of test data if you test on the boundaries. That's it. Do you have questions?
Oh my, do we have questions? So why don't you go ahead and stop sharing? So
yes.
What I'm going to do is pass on over here. I guess I can grab the share.
Stop sharing.
There we go. We've got a lot of really good questions. So let's dive in. We did the IDs. We had a question about unit testing in SQL Dev, answered that. Here's a good one. You and Dee will like this one. And Dee, I'm going to turn on your camera or ask you to start your camera. Is there not a paradox inherent in writing test code in the code we are testing? How do you test the test code, and how do you test the test code for the tests of the test code, etc.? Maybe this is more a question for the UTPL SQL team. So they built the testing framework in PL SQL, and I guess the question is, what if the testing framework has bugs in it? But I'd say in general, that's so. If anybody on the UTPL SQL team wants to speak, I can unmute you, or you might be able to do that yourself. I'm not sure, but in any case, it seems like this is certainly a classic sort of challenge that we have whenever we're using a framework. You got to trust your framework. So I suppose the question might be, what does the UTPL SQL team do in terms of automated testing of UTPL SQL? Oh, wait a minute. Joel says, sorry, I didn't mean that the framework was wrong, just the code. Right, okay. Putting aside testing the framework, right, Jasmin and Dee, you're writing PL SQL packages to test the code. So any thoughts about how are you sure that your tests are valid?
With running them with different data over and over again, probably. It's always, it's that thing you really can't test, the test itself.
It is a very meta question.
Yeah, for me, it's important that it's getting reviewed by other developers. So 4 eyes are better than 2.
Yeah, and there is not, like, we have to ensure that there's no logic at all in the test. All the tests will be doing is just set up, test, call the procedure that's actually doing the business logic, and tear it down. So no branching things or, doing all sorts of coding in the test itself.
And I think the way to make that clear in terms of the context of this talk is that since you're using UTPL SQL, pretty much all of the testing logic is buried inside the framework. So as you were showing us both of your codes, there's very little actual logic that you're writing to set up and run your tests. But if you're doing something from scratch yourself, not even a separate framework, but you're literally building your kind of test code units, then you've got a bigger challenge around validating the logic of your test code. Okay, so moving on. Any thoughts on writing code for testability and for testing private functions which you don't want to make public in the spec? So just to preface that, the code that I've written, and I still do it, and certainly a lot of the code I've seen from others, is almost virtually untestable. One procedure that takes in 16 parameters, passes back 14 out arguments, modifies 16 tables. Test that. So what do you do around how you're writing your code to make it more testable?
You said the how to test private functions?
That's a separate one.
Oh, that's a separate one.
That's the second one. That's
okay.
What can you do in terms of how you write your code to make the code more testable?
Oh, I always try that procedures are doing one thing and not multiple. So I can also test one thing and doesn't need to test multiples. So that could be one way to do it. Split it if they do multiple things.
Any thoughts, Dee?
Yeah, one of the tips I shared was to separate out the logic and the transaction control. The other is what Jasmin just said, modularize the code and try to test for behaviors instead of testing each procedure itself. Find out what the behaviors are of the scenario you're trying to implement and test for that. That way you'll avoid testing every private function and every procedure. You'd rather, underneath there could be many private functions, but your behaviors could be talking to those many private functions, but your test is still one test, testing the behavior.
Okay. So, that's a good point to keep in mind. My thought about writing code for testability is following good guidelines for writing maintainable code is pretty much the same thing as following good guidelines for writing testable code. If you can't understand what the code is doing by looking at it, if you find it difficult to maintain that code, then you're going to have a heck of a time testing it. And I think the basic idea is follow modularization techniques, create separate modules for separate functionality, and document the dependencies as well. Okay, yeah, there's a whole bunch of Q&A going on in the Q&A stream here around using conditional compilation and accessible by or whitelisting for testing private functions procedures. So you've got a package spec, it's got 2 programs in it, and they're big complicated programs. You look in the package body and there are like 50 different private procedures and functions. So you've done all this great modularization, but it's all hidden away. And one point that Dee just made is, well, what you want to do is test behaviors, not units of code, so it doesn't matter. One argument could be, it doesn't matter if it's got 50 subprograms, you just test it at that high level. But if you do have some of that code, some of the code in the package body, and Jacek from the UTPL SQL team mentioned this, that can be isolated, then you might consider isolating it, taking it out, putting in a package spec, say a utilities package, and then you can test it directly. But a technique of exposing in a controlled way private subprograms would be to use conditional compilation, $, and then a flag you can say in your package spec. Essentially, if I'm testing, expose this in the package spec when I compile it. But in production, hide it away. Nobody can use it unless you've turned on your testing flag. So those are some of the comments from Q&A. And I think there was one more. Oh, one other person mentioned the idea of cloning your database for setup and teardown, whether there's a clone DB or using multi-tenant in PDBs. Do either of you have experience with that?
I have a little experience with that. We had one project where we did that. The challenge was that we couldn't review the changes in the clone database. So if I had to change my test data, I would have to change systems and it wouldn't be made explicit in a pull request. So management gets a lot more difficult.
Okay, thanks. And the last question I have, I think, or close to it, is there a downside to putting multiple tests in one test procedure? For example, I have a loop through a table and I test all 100 cases on the table. I noticed it shows me all the failures, example 4 failed. Should I be setting up 100 different test procedures instead, or should I make more of a dynamic test procedure that I call 100 times? Is that clear?
I don't know. I didn't understand. Sorry.
So Olsen, Stay, if you want to try to clarify that.
Yeah, maybe rephrase a little bit.
I mean, I think probably it's similar to the ideas we just talked about making your testing more manageable. But so I think generally breaking things up into smaller chunks that, for example, you can call individual tests and not have to do all 100 is probably going to be advantageous because then you can test more quickly or in a more focused way. And let's see what else I've got. Just more about conditional compilation and flags in PL SQL. Okay. Can you do multiple assertions in one test procedure?
Yes.
Sure.
Yes.
Right?
Mm-hmm.
So the test might have any number of different assertions. Okay, and that's what he meant by the loop, or she, sorry.
Okay. Yes, you can do multiple assertions in one test procedure.
Okay.
But as
Any
long
other,
as
go ahead.
behavior, sorry.
Sorry.
Yeah, a single behavior, but multiple assertions is still fine.
And Vidar has a comment that you can test several things like attributes in a test, but only one concept at a time to keep the test simple enough. That's an interesting way to look at it. And I got one big plus on my cute puppy. Yes, he is very cute. Okay, I think we've got it pretty well covered. Any other questions or comments before we close down for today, right on the hour? All right, I'm going to share my screen. So thank you all for attending. Hopefully you got a lot out of the session. It is being recorded. We will post a link to the recording plus the presentations and other testing resources on the page. So just go to asktom.oracle.com, drill down into office hours, PL SQL. You can also grab this URL and you can always bookmark that to go to the latest session. And then if you click on all sessions, you can see all the past sessions, watch the recordings. Here, for example, is the first session on testing we did. Real world testing your PL SQL code. And right from this page, you've got access to the video. You can ask questions when you're signed in, submit feedback. And thank you so much to my speakers, Jasmin and Dee. It was really great having you on again.
Thank you for the opportunity.
So happy New Year's to everybody. Hope you have a great year of coding in Oracle database and building fantastic applications. And I look forward to seeing you in a future office hours session. Take care, everybody.